Hey everyone, welcome. Today we're tackling a slightly quirky Leetcode problem called rabbits in forest. It sounds a bit like a riddle, but don't worry, we'll break it down step by step and figure out a clean way to solve it. Ready? Let's go. Okay, so here's the setup. Imagine a forest with rabbits of different colors, but we don't know how many rabbits or colors there are. We ask some of the rabbits just one question. How many other rabbits have the same color as you? We get a list of their answers. Our job is to figure out the smallest possible total number of rabbits that could be in the forest, given these answers. The constraints tell us the number of answers we get isn't huge, and the answers themselves are within a reasonable range. Let's walk through the first example. The answers are 1, 1, and 2. Okay, consider the rabbits who answered. If a rabbit says, it means there's itself, plus one other rabbit of the same color. So a group of 2 rabbits total for that color, right? Let's say these are red rabbits. Since we have 2 rabbits answering, they could totally be the 2 rabbits from this single red group. So that accounts for 2 rabbits minimum. Now what about the rabbit that answered? If a rabbit says it means there are itself plus 2 others of the same color, so a group of 3 rabbits total. These rabbits must be a different color, say blue, because the red rabbits answered. This blue rabbit we talked to is one of the 3. We didn't talk to the other 2 blue rabbits, but they must exist to make the answer valid. So this answer implies a minimum of 3 blue rabbits. Putting it together, 2 red rabbits plus 3 blue rabbits gives us a minimum total of 5 rabbits in the forest. Make sense? Let's try another one. 3 rabbits all answered. If a rabbit answers, how many rabbits of that color must there be in total? Well, itself plus 10 others, so 11 rabbits. Now, we have 3 rabbits who gave this answer. Could they all belong to the same group of 11 same-colored rabbits? Yes. A group of 11 can contain, well, up to 11 rabbits who would all answer. Since we want the minimum total number of rabbits, we assume they do belong to the same group. We just happen to interview 3 out of the 11 rabbits of that color, so the minimum total number of rabbits needed is just 11. Okay, so what's the core idea here? It seems like the answer a rabbit gives tells us the size of its color group. If a rabbit answers, there must be x plus 1 foot rabbits of that color in total. And notice, all rabbits of the same color must give the same answer. If we see multiple rabbits giving the same answer, say they could belong to the same group of x plus 1 foot rabbits, or they might belong to different groups of x plus 1 foot rabbits. But all groups where rabbits answer must have the same size x plus 1 foot. Since we want the minimum total, we should try to pack as many rabbits with the same answer into the same color group as possible. So a good strategy seems to be, first, let's count how many times each specific answer appears in our input list. We can use something like a hash map or a counter for this. Then, let's look at each unique answer. Say, suppose rabbits answered. We know each of these rabbits belongs to a group of size x plus 1. How many complete groups of size x plus 1 foot do we need to account for these rabbits? Think about it. One group of size x plus 1 foot can explain up to x plus 1 foot rabbits answering. If we have more than x plus 1 foot rabbits answering, we definitely need a second group of that color. Well, a different color, but same group size and answer. So if rabbits answered, and each group has size x plus 1 foot, the number of groups we need is the divided by the group size, rounded up to the nearest whole number. This is called the ceiling function. For example, if 7 rabbits answered, group size 3, we need ceil, 7/3, which is 3 groups. Once we know the number of groups needed for answer, the total rabbits contributed by this answer is simply the number of groups times the size of each group, x plus 1 foot. We just do this for every unique answer we saw and add up the results. Alright, here's the Python code that puts this idea into action. It looks pretty short, right? Don't worry if it's not immediately obvious what each line does. We'll quickly walk through the main parts. First off, we use counter from Python's collections library. This is super handy. It just goes through the input list answers and counts how many times each number appears. So if the input was 1, 1, 2, counts would basically store 2, 1. Easy peasy. We also initialize our total rabbit count to 0. Now we loop through each unique answer x and its corresponding count that we found. Inside the loop, first we calculate the size of a group for this answer. Group underscore size is just x plus 1. Then comes the slightly tricky bit. Calculating the number of groups needed. We need to divide count by group underscore size and round up. A neat integer division trick for ceil a didre b is a plus b dre 1 didre b. Here, since group underscore size equals x plus 1, This becomes count plus x plus 1, bderade dderade b, shield, dderade b, bderade dderade b, dderade b, x plus 1, which simplifies to count plus x dderade b, count plus x dderade b, bderade b, x plus 1, or count plus x dderade b, count. This gives us num_groups. Finally, we add the total rabbits for this answer to our overall total, that's num_groups, multiplied by the group_size. And after the loop has finished processing all the different answers we found in the input list, we just return the total _rabbits we've accumulated. That's our minimum possible number. So how efficient is this approach? For time complexity, we iterate through the input list once to count the answers, that's order n, where n is the number of answers. Then, we iterate through the unique answers. In the worst case, all answers could be unique, so this loop might also run up to n times. Overall, the time is dominated by processing the input, making it big O of n. Pretty good. For space complexity, we use a counter or hash map to store the frequencies of the unique answers. Let's say there are unique answers. The space needed is proportional to the number of unique answers, so it's big O of u. Since u can be at most n, you could also say it's big O of n space, in the worst case. Okay, let's quickly recap the main points. The crucial insight is that a rabbit answering means it belongs to a color group containing exactly + 1 foot rabbits. Our strategy was to count how many rabbits gave each answer. Then, for each answer given by rabbits, we calculated the minimum number of groups of size x + 1 foot needed using ceiling division. The final result is just the sum of the sizes of all these required groups. This gives us the minimum possible total number of rabbits. Hope that explanation helped clear things up. If you found this useful, hitting the like button really helps. Consider subscribing for more Leetcode breakdowns, and feel free to leave a comment if you have any questions, or perhaps a different way to think about it. And hey, if you're feeling extra awesome, there's always the virtual Boba Fund. Keep practicing, keep coding, and I'll see you in the next video.